All right, so this sadly is the last lesson for algebra. I am sorry that we couldn't finish it in person. I wish that I could see all of you in the classroom. This class was a very special class. I wish everyone the best of luck with your futures. Okay. I also wanted to, as this is the last lesson, I want to talk about why I feel algebra is so important. And maybe, and this is just my feelings towards the subject. I just wanted, this is the last lesson, so I wanted to talk about that. Why algebra? Why I think algebra is important. The reason I think algebra is important is because it gives you every other subject that deals with numbers. So for instance, when you think about geometry, you start including ratios and the Pythagorean theorem, but there's still, that basic foundation of algebra. When you start dealing with chemistry, you're dealing with converting between units, but you're still going to be doing algebra. When you go into finance, when you're going into subjects like that, how you balance a checkbook, how you do stuff like that, you're adding and subtracting numbers, quantities, you're still, using algebra. So the reason algebra is important is not necessarily because it's used in all these different fields. It's because it allows you to go into and learn about all these different types of subjects. So if you want to learn a subject, being good at algebra, there's a reason you want to be good at algebra. It's because it allows you to go into those different types of subjects, and learn. So I want everyone to learn. Try and learn those new things. Okay. All right, so this is the last topic. We're going to talk about graphing inequalities. So we're going to get into that. Graphing inequalities. When we think of inequalities, what we're thinking of stuff that's like not quite equal signs. So we're thinking greater than or equal to, greater than, okay, stuff like that. Now I'm going to write some notes first off to get you going, and then we'll go from there. So when we use the symbols greater than and less than, so those values don't include the quantities. So when we use symbols greater than and less than, we're referring to not including the line that we're going to be graphing inequalities, particularly lines. So we're not wanting to include the line, so we're wanting it to be like a dashed line. So we're wanting to include all points not including the line. So we use these symbols for dashed lines, stuff that looks like this. I don't know why there really is that convention, because you start learning later on, there's really not much of a difference between dashed lines and solid lines, but that's a side note. What's important is that the dashed lines, for this subject, you're going to be using symbols greater than, less than. Also a solid line, so we did greater than or less than, so we use the symbols greater than or equal to, and less than or equal to, including points up to the point, so we're focused in on the line itself. So for solid lines. And a solid line, we can think of something that looks more like this. So we're wanting to include values on that line. Now, I want to talk about a certain property of numbers. And the property of numbers that I want to focus in on is known as trichotomy. So it's called trichotomy. It's kind of a cool subject. Trichotomy. All right, so what's your favorite number? You in the front, what's your favorite number? So -5. So if you have a number, what trichotomy states is that, so you have the number -5. Let's say I choose any arbitrary real number that I want. Arbitrary, completely random. So let's say I choose the number 10. Okay, so I choose the number 10. So what trichotomy states is that either 10 is less than -5, 10 is equal to -5, or 10 is greater than -5. So a number can either be less than, equal to, or greater than another number. Every single real number exhibits trichotomy. And what's important is that it has to be in one of these locations. So right here, we're saying that this is true. So 10 is greater than -5. This is true. So it has to be in one location. It could be here, here, or here. So this is what's important. So one spot. That works for all real numbers. So there's that property there. So, and when we think of, greater than, it's above it. When we think of it as equal, it's right on it. When we're thinking less than, you're thinking height in context is below it. So you're thinking of a number less than that number. All these other statements here and here, they're false. Know that this is not true. 10 does not equal -5, and this would be also false. But trichotomy states that exactly one statement will be true. Now I'm going to go into why that's important for graphing inequalities. All right, let's say I wanted to graph the line, y equals 3x plus 9. Don't write this part down because I'm going to change it in a second. But let's just say I wanted to graph that line. So what this line would look like, we know that it's y-intercept. So where it crosses the y-axis, here's my y-axis. At that point would be 9. The slope would be 3. So it'd be rise over run. So my rise would be 3 units up. My run would be 1 unit over. And that's what that line would, that's just a sketch of that line there. Another way of thinking about it is that if I take this line here, and I like this notation in particular here, if I think of a line, and along this line, I specify any random x value, any arbitrary number, any value I want. Let's say my x coordinate was x. Well, then the equation of the line states that y equals 3x plus 9. So my y coordinate for that point must be 3x plus 9. All right, so let's not think even in context of what y might be equal to. Let's just consider, for any value x, we can choose what my y value is. My y value would be 3x plus 9. Again, so for instance, the equation of this line, if we plug in the number 10 for x, well, we go 3 times 10 is 30, plus 9 is 39. So that point would be on my line. And that's what the equation of a line is. So we can just think of something, a line, just like this. If we're having any point we want, we can specify it. Now what I'm going to do is I'm going to consider a vertical line right here. Now, what's important about this vertical line is if I choose a point, let's say, because we're graphing inequalities, a number can be either above or below this point. It could be below the line, or it could be above the line. Right, and what do you notice about my x-coordinate? Here and here, it's a vertical line. Did I go over any amount in the x direction? I didn't move this way. I'm right here. So my x-coordinate is x here. It also must be x here. And then, so my x-coordinate, so it's x here. I'm looking up. I didn't go over any direction in the x direction. So my value, my x-coordinate also must be x. Right there. Now, a way of thinking about this is that, so here's 3x plus 9. This value is a specific number. So when I plugged in 10, we had the 39 that was spit out. So this value is a specific number. Now, if we're wanting to choose a point that is above that line, it must be above a number that is above 3x plus 9. So we're thinking of a number that is above 3x plus 9. And if we think about here, so we have x, here's 3x plus 9, here's my height. It's a specific value. We're just trying to think of, a value that is below that number right there. So some number that is below 3x plus 9. All right, and this is what is important about so this is why I tied in that trichotomy aspect. So what I'm going to do is I'm going to take this line over here, and I'm just going to kind of visualize, this axis right here. So this y-axis right here. So I'm considering that, just my height. But right here, we see the height is 3x plus 9. So right here, it's 3x plus 9. Now, what's important is that I was talking about trichotomy earlier. A number can be either greater than it, equal, or less than that other number. So this is just a number right here. Here's 3x plus 9. I could find a number that's a little bit above it. So I could find a number that would be above my line. So a number that's a little greater than 3x plus 9. So this number over here, this value corresponding to this, I'm going to move this down. Actually, I'm going to move this up a little bit. This would have to be greater than 3x plus 9. Here's 3x plus 9. Any number greater than 3x plus 9 must be above it. This is a number greater than 3x plus 9. And if we think about, so this is just some quantity, it could be 27. If we're thinking of a number that is below it, so this number below it, negative 10, would be less than that number, a super small number. So we're thinking of a number that is, so it could be, in fact, less than 3x plus 9. All right, and what I'm going to do particularly is choose my value for y to be any one of those values. So, and trichotomy states that any number must be greater than, equal to, or less than that value. So the situation where I have a number y that is greater than 3x plus 9, well, that must be the situation where it is above my line. So therefore, this is the symbol for therefore. It's got 3 dots. Y must be greater than 3x plus 9. Because we're seeing y must be a value that is greater than 3x plus 9. In this situation here, where the point lies directly on my line, we know that y must be equal to 3x plus 9. So over here, when the point lied on my line, we say y was equal to 3x plus 9. In the last situation, when I found a number that was less than 3x plus 9, that was the situation where it must have been below 3x plus 9. So therefore, this last situation was where y was less than 3x plus 9. So what's important is that when we think of above, we're thinking greater than, a y-coordinate that is greater than that expression right there. When we're thinking below, we're thinking of a y-coordinate that is less than just that expression right there. When we have a line, we have that 3x plus 9 right there. So we're thinking of a value that is equal to it. So let's say we were trying to graph some inequality where we have y, let's say we're asked to graph y is less than 2x minus 7. Well, what this stands for, so when I think of this right away, don't concentrate on what this is. So we have some scratch work. Consider just this part of this inequality, the 2x minus 7. Just consider this expression right here. If we were going to graph that line, y equals 2x minus 7, so don't conflate, don't intertwine, this y and this y. These are totally different concepts. But what happens is they kind of blend together, okay? So if we were going to graph this line right here, y equals 2x minus 7, so I have y equals 2x minus 7. Well, we're thinking of a line, so it's mx plus b. So b must be negative 7. B is my y-intercept, so this point over here, my y-intercept must be 0, negative 7. And if we're going to graph this line, so the slope is right here, so the slope m must be equal to 2, so this slope would just be 2 for this line. So the slope of this line would be 2. You think about it as rise over run, so the 2 over 1. You think of it like that as well. So rise here is 2, run is 1, so this is 1 unit. This is 2 up. And from there, so we could graph this line y equals 2x minus 7. So this would be the line y equals 2x minus 7. Now, if we're thinking anything that is less than it, less than 2x minus 7, any value along here that is less, so here's a value, I'm wanting something less than it, my y-coordinate is going to be less than that, it's going to be below it. So if I was going to graph this thing, all I am is interested in just this region below here. Less than means below. Now the question is, do I want to include this line y equals 2x minus 7 right here? So do I want to include points of this line do I want this line to be dotted, or do I want it to be solid? Do I want it to be dashed or solid? Just one line here. Well, if I'm going to graph the line y is less than 2x minus 7, it cannot quite include this line right here. So this line, we don't want to include the points along this line. This line right here must be dashed. So if we're thinking about this line, we want it to be dashed. So I might choose another color. So this would be this region of the graph, not including the line, so this is a dashed line here, would be y. This region, this shaded region, would be anything that would be less than 2x minus 7. Now, if there was a less than or equal to symbol, this line would then be solid because we're wanting to include points along this line as well as the shaded region. Let's do one more. Let's say we were asked to graph. So we did, let's try and switch it up. Let's say graph y is greater than or equal to, let's do negative 5 over 2x plus 7. Again, don't concentrate on this symbol. Write some scratch work, because what is important is thinking about what does the line y equal to negative 5 over 2x plus 7, what that looks like in order to graph this thing. I start off with some scratch work over here. I just am concentrated on that value over there. And so I draw my x-axis right here, and I draw my y-axis right over here. Well, my y-intercept is 7, so it's 7. So this point up here, it's not going to be down here. This would be negative 7. It must be, so here's my point, 0, 7. Now my slope, well, my slope is negative here. So my function, it's not going up, it's going down. I'm going downhill. So it's negative, so it must be going down this way. All right, so my rise over run. So if I go over 2 units in the x direction, and then my rise, so this is my rise, how much I go up and down. So it's rise over run. So I must be going down 1, 2, 3, 4, 5 units down this way. And so my function of my line must look something like this. I'll make it a little more straight. So my line looks like this. So it has a slope, it's negative, so it's going down. So here's so rise 5 over run 2. I have my y-intercept, so I graph the line y equals negative 5 halves x plus 7. 5 over 2. All right, now we're wanting to graph this, so now we ignore this part over here. Do I look above or below this line right here? Here's my line. We're looking at anything that is, so before it was below, this is now, it's saying above, anything greater than this line. So we have this line here, anything greater than it must lie above it. So we're concentrated on this region over here. Now the question is, can I include points here, here, here? Can I include these points? Do I want to include them? So this right here must be a solid line. And another way of thinking of why this situation here must be a solid line, why these points are included in this shaded region here, is because when you think about y is greater than or equal to negative 5 halves x plus 7, what this literally translates to, what this means is that y equals negative 5 halves x plus 7. And that's that line right here. It can equal it, or it's greater than it, so it lies above it. So, or y is greater than negative 5 halves x plus 7. So the symbol greater than or equal to means literally that it could be equal to or it could be greater than. Right? And that is how you graph inequalities.